Hello, this is the 2009 MAT. So as usual, I will do the multiple choice questions at the start and put the other questions in separate videos. So kicking off with A then, what is the smallest value of this integral as A varies? So, right, we're going to probably have to do 2 bits of calculus on this, I suppose, because we can do the integral. We'll just get something as a function of a, well, as it says so in the question here. So let's actually do this first of all. I'm going to expand it out just because I find it a bit easier to visualize it then. So we've got what, x to the 4 minus 2ax squared plus a squared dx. So let's integrate that then. So I function of a is going to be x to the 5 divided by 5 minus 2/3 of ax cubed plus a squared x, and that's between 0 and 1. So we've got a fifth minus 2/3 of a plus a squared, and we want to minimize that. So we're going to want to do di dA minus 2/3 plus 2a. And you can see that's going to be a minimum because our second derivative is going to be 2. So we've got a minimum at a will have to be a third. And we want the actual integral, the value of the integral. So I of 1/3 is equal to a fifth minus 2/9 plus a ninth. So we got a fifth minus a ninth. So that is going to be 9 over 45 minus 5 over 45, which is equal to 4 over 45. So B. That was quite long-winded for a first question. Point on the circle that, which is closest to the origin, is at what distance from the origin? Right, this then is going to be, well, the centre of this circle is always the negative of half the coefficients of the x and y. So that's going to be minus 3 minus 4. That's just completing the square, isn't it? And then if we were going to carry on completing the square, we'd have to take off 3 squared and 4 squared on the left-hand side. So add that onto the right-hand side. So that would be adding on 5 squared. So radius is going to be 10. Okay, so we've got... the centre is 5 away from the origin, but the radius is 10. So we're going to have the centre there, the origin there, and then so that's 5 getting from the centre to the origin. We've got another 5 to get to the radius, the circumference, to complete that radius of 10. So the origin is going to be 10 away, from 5 away, I should say, from the circumference of the circle. That's what we want, isn't it? The point on the circle closest to the origin, at what distance from the origin? Yes, so the origin is halfway between the centre and that point, distance 5. Right, that was okay. Given a real constant c, the equation x to the power 4 is x minus c all squared, has 4 real solutions, including possible repeated roots for what values of c. Right, let's square root. That's going to give us 2 equations because we're going to have a plus and a minus. So we'll have x squared is x minus c, or we're going to have x squared is c minus x if we have the negative square root. So that gives us x squared minus x plus c is equal to 0. And then this one will give us x squared plus x minus c is equal to 0. So now we can look at our discriminant. B squared, so 1 minus 4 times 1 times c, minus 4c. And that has to be, not equal to 0. We want possible repeated roots as well, 4 solutions. So greater than or equal to 0 for that one. So that means that c is going to be less than or equal to a quarter. And then we do the same thing over here. We're going to get 1 plus 4c. Has to be greater than or equal to 0. So c will be greater than or equal to minus a quarter, I should say, on that one. So that's between minus a quarter and a quarter, which is B. D, smallest positive integer n, such that this sequence here is greater than or equal to 100. Right, okay, so we're going 1, and we're adding on the odd numbers, we're taking off the even numbers. So we're going to have an odd number in the sequence because we're going to be going 1 minus 1, then 2 minus 2, 3 minus 3, 4 minus 4. Okay, so that is for n is 1, 2, 3, 4, 5, 6, 7, 8, etc., etc. So this is, we're adding 1 to n, dividing by 2. We need it to be odd. So we're doing n plus 1 divided by 2 has to be greater than or equal to 100. So n has got to be greater than or equal to 200 minus 1, 199. C. Right, that was quite a nice one as series questions go. In the range 0 to 2 pi, the equation 2 to the power of sine squared x plus 2 to the power of cos squared x is equal to 2. How many solutions does it have? Right, so this is clearly the substitution question. So let's get rid of, say, the cos squared bit. We could get rid of the sine squared, but doesn't really make any difference. So 2 to the power of sine squared plus 2 to the power of 1 minus sine squared x is equal to 2. So that is 2 to the power of sine squared x plus 2 times 2 to the minus sine squared x is equal to 2. So now we can do our substitution. Let y is 2 to the power of sine squared x. This gives us y plus, so that 2 divided by y is equal to 2. Y squared plus 2 equals 2y. Y squared minus 2y plus 2 equals 0. How many solutions do we have for this? So b squared 4 minus 4ac minus 8. So we've got no solutions in that range. A. Right, that was good. Quite a sneaky one for a substitution. The equation in x, 3x and 4 minus that. Okay, how many? There's 4 real solutions when? There's something. Oh, right, we've got k at the end here. So k is varying. That's just moving the graph up and down. We've got translation in the y direction. So how many solutions? When do we have 4 real solutions? So this is a quartic, a positive quartic. So if that's our x-axis and we want 4 solutions, real solutions, it's going to have to look something like that. So we need minimum, maximum, minimum, and we need those to be negative, positive, and negative for our y values. So we're saying, yeah, y is less than 0 for these ones, y is greater than 0 for that one. That will then give us our 4 real solutions, because that's the only way we're going to get 4 places it crosses the axis. Right, okay, so we need our, well, I'm going to call this y equals, ignore the 0 at the end. We'll do a dy dx, get ourselves a 12x cubed minus 48x squared plus 36x. So, oh, we can certainly divide by 12 on all of this. Well, we want to set it equal to 0 and then, yeah, divide by 12. So we want x cubed minus 4x squared plus 3x is equal to 0. So we've got x equals 0 is certainly one of them. And then can we factorize? Yeah, we'd have a minus 3 and a minus 1. So we'd have 1 and 3. They're going to be our roots. So let's go through these. They're going to be, well, I say roots, these are our turning points. So that's 0, that is 1, that is 3. Right, so let's go through each one of these in turn. So when we put x is 0 in here, we need something which is less than 0 overall. So we've got all these zeros and then k. So k has got to be less than 0. That's dealt with the first one. We put 1 in and it's got to be positive. So 3 minus 16 plus 18 plus k, that has to be greater than 0. So we've got k has to be, what have I ended up with there? We've got 5 plus k is greater than 0. So k has got to be greater than minus 5. So how's this? We haven't had a 27 turn up yet. Assume that's going to be for the 3. Although we're already in the zone of D already. D's already come out. at less than 0 and greater than -5. Let's try with the 3 anyway. So let's put that in. So we're going to have 3 times, what's that, 81 minus 16 times 27 plus 18 times 9 plus k has got to be less than 0. This, I'm assuming, is coming out at being 27. I wonder if that's going to help us in our working out of all of this. Yeah, it might do, you know. Will it? Yeah. Okay, let's try and get 27 as a factor. So that would be 9 times 27 minus 16 times 27 plus 6 times 27 plus k is less than 0. So we've got 15 minus 16, so that's minus 27 plus k. So yeah, k is less than 27 on that one. So yeah, it helps looking at the answer there to see we can factorize that 27 out. But yeah, that doesn't affect anything because k has to be less than 0. So saying it's got to be less than 27 is no great shakes. So it comes out at D, which is fine. Yeah, that was a nice question. I like that one. Geez whiz, these look horrible for identify the graph question. Graph of all those points x, y in the xy plane which satisfy the equation sine y is equal to sine x. Drawn in which one? So what are the variations here? We've got variations in, well, gradient. We've got this weird one down here at C where they're going positive and negative. We've got how often, that's also cutting the axes a lot more frequently. We've got, is it going through the origin? That's a good start. Well, yeah, if we put y 0, x is 0 in, then it's fine. So we need to go through the origin. So it's not going to be B, it's not going to be D. It's going to have to be A or C. How often are we going to be coinciding here? Well, if we've got y is equal to, yeah, so we've got sine y. So we want to have y equal to 0. So how often are we going to be cutting the x-axis? We're going to cut the x-axis every pi because that's the cyclic nature of sine x. So yeah, we're going to have to cut it there and there. That's every pi. This one's doing every 2 pi. So it's going to have to be C, just based on how often it's cutting the x-axis. You'd have the same on the y-axis as well. Both of them are cutting every pi. So yes, so it's going to be C. Then we've got H. When the trapezium rule is used to estimate that integral by dividing the intervals 0 to 1 into n subintervals, what answer do we get? Oh, how tedious is this going to be? Actually wanting us to apply the trapezium rule. Right, okay, so we're dividing it into n subintervals. So our width, our strip width is going to be 1 over n. So we're going to have then, doing our trapezium rule, is going to be, so we get h over 2, don't we? So 1 over 2n at the start. Then we've got the first value, the last value. So the first value is 2 to the 0, which is 1. The last value is 2 to the 1, which is 2. And then we've got 2 lots of everything that's going in between. So 2 lots of, so the next one along is going to be 2 to the power of 1 over n. Then we're going to have 2 to the power of 2 over n, etc., 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 up to 2 to the power of what is going to be n minus 1 over n. They're going to be all of our strips. So what have we got there then? We've got a geometric series that we're going to want to add up. We can include this 2 here as well inside it. So let's say then, so this, with this 2 at the end plus everything that's here in the bracket, we've got a, we can put a 1 inside the bracket and just get rid of that 2, can't we? So we're saying we've got 1 plus 2 to the 1 over n plus 2 to the 2 over n plus 2 to the 3 over n, etc., 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 going up to n minus 1 terms on this, haven't we? Yeah, we're gonna, oh no, we have got n terms because we got the 1 at the start. Yes, and then we start counting from 1 up to n minus 1. So we have got n terms. So our sum to n is going to be a, the first term is 1. multiplied by, so we want r to the n. R is our 2 to the 1 over n. And we want to do that to the power of n. Take off 1. And then do r minus 1 on the bottom. So 2 to the 1 over n minus 1. So that is just 2 minus 1 on the top. So that gives us 1 over 2 to the 1 over n minus 1, which at least is appearing in 2 of the answers, which is pleasing. So that gives us the bracket and the 2. So all in all, we got 1 over 2n. And then we've got 1 plus 2 over 2 to the 1 over n minus 1, because we need to remember that 2 there. And that is B. That's a horrible question with little to be said for, we haven't even gained anything really from doing it. It was just a bit tedious. Right, I. Hopefully this will be better. Polynomial, horrible looking thing, which has got x's and n's in it, has x squared minus 1 as a factor for which values of n? Okay, so, God, these look really horrible. So this has got to be something to do with factor theorem then, you would have thought. But we don't do factor theorem with x squared minus 1. But this is difference of two squares. So we can say x plus 1, x minus 1. So we have got two factors there, which have got to satisfy things. So let's try putting these in. We've got f of 1 and f of minus 1 we want to put into this. So f of 1 then gives us n squared minus 25n plus 150 equals 0. For minus 1, what are we going to get? It's going to depend on the power of, well, if x is minus 1, the last one, we know we're getting minus 150 because we've got x to the power 7, so that gives us minus 1. The first one, 2n plus 3, that's odd as well, 2n plus 3. So we must have minus n squared at the beginning. In the middle, we don't know about n plus 1. So this could be plus or minus 25n. And we need to satisfy all three of these equations then, don't we? If we're going to get a solution, all of these have to be true. So what have we got? Can we solve the first one? Yeah, we've got 10 and 15 for this, haven't we? If you factorize the first one, we're going to get n minus 10, n minus 15 is equal to 0. So we've got n is 10, n is 15, but they also have to satisfy both of these equations down the bottom. For n is 10, n is 10, n is 15. Oh, that also resolves our problem with a plus or a minus. So if n is 10, then we're getting a negative. Is that right? We're getting a negative in the, we've got an odd power if n is 10. So x to the 11 would be negative. With that negative there would make it a positive. So we'd get minus n squared plus 25n minus 150 equals 0. So let's just flip the signs on all of these just to make it a bit easier. And no, that's what we just solved. So if n is 10, then we can have n is 10 or n is 15. Right, so that's still consistent. Everything's okay. If we've got n is 15, then we've got an even power here. So we'd have a change of sign. So we'd have minus n squared, and we'd have minus 25n, and we'd have minus 150 is equal to 0. So flip the sign on everything. N squared plus 25n plus 150 equals 0. So that's going to factorize as well. That'll be n minus 10 and n minus plus 10 and n plus 15. I'm thinking of what the end result would be because it's going to be the opposite of what we had before, equals 0. So that would be that n is minus 10 or minus 15. Well, that's not consistent with n being 15. We've got a contradiction here. So that doesn't work. So we can't have n is 15. So it must be just n is 10. That's the only way we can get things to work, because n is 15 gives us a contradiction in the third equation. Okay, yeah, that wasn't too bad. Quite fiddly. It was a difficult question, but it was certainly manageable. And then J, right, the number of pairs of positive integers x, y, which solve that equation. X cubed, we've got a cubic here. In x and y, are these gonna factorize? Because that is 2 cubed there for an 8. So, and then yeah, I think that does, doesn't it? So if we add x plus 2y cubed, what would we actually get if we were cubing that? We'd get x cubed, and then we'd get 3 times 2, so that would give a 6 coefficient. Then we'd have 3 times 4 would give a 12 coefficient, and then an 8. Yes, so that does factorize to that, which is 2 to the 30. We can do a cube root without wondering about any negative signs. That's how cube roots work. So x plus 2 times y is 2 to the 10. Right, what's that telling us? So we've got the number of pairs of positive integers. So at least it's a more simple equation. So what are we going to have then? We're going to have, well, x is going to have to be even, because we've got an even number here and an even number there. So x is even. Does that help us in any way? So if x is, say, 2, then what would happen? We're going to have, well, 2 to the 10 minus 2. How many ways are we going to be able to do this? X is going to go all the way up. How many pairs? Yeah, so x can go from pairs of positive integers. So we can't have 0. So x equals 2. Then it can go 4. Oh, but it's got to equal 2 to the 10. Yeah, I'm not really sure what's going to happen with this. Are we going to have every single value up to this? Yeah, we might do. We can go all the way up to 6, 8. Yeah, because you can still have a value for y. It doesn't have to be a power of 2. It just has to be even. So y would then be equal to 2 to the 10 minus 2, 2 to the 10 minus 4. I know this is all fairly obvious, the numbers I'm writing out. I'm just trying to see what the pattern is on all of this. 2 to the 10 minus 6. So you're going to do this all the way up to 2 to the 10 minus 2. So, and there's going to be a pair for every single one of these. So how many steps are there going from 2 up to 2 to the 10 minus 2? Right, so 2 to the 10 minus 2, and we're going every other number. So we just need to divide that by 2. And that is going to be the number of steps that we're doing. So that is 2 to the 9 minus 1, which is C. I mean, it's satisfying that it's one of the ones that they've given. Let's just double check that I'm doing the right thing. So we've got to count all the way up to 2 to the 10 minus 2 in steps of 2. We can't go to 2 to the 10 because that would mean y is equal to 0. And y has to be greater than 0. It's a positive integer. So yeah, we're going up in steps of 2 from 2 to 2 to the 10 minus 2. So if we were just counting all the way up to 2 to the 10 minus 2, we would have 2 to the 10 minus 2 numbers. But we're going only half of the numbers. So we divide it by 2, which gives us 2 to the 9 minus 1. Yeah, that definitely works. Right, okay, that was tricky as well. I mean, it's tricky to spot the factorization at the beginning, but then, yeah, working out these pairs. That's, again, this is a bit like with some of the other questions that we have where you've got some kind of series or pattern where you're trying to spot what the pattern is. Just writing out those steps of, well, what pairs of x and y can we have? I know they're really obvious numbers, saying, oh, yeah, well, it's going to be 2 and then 2 to the 10 minus 2. Obviously, that adds up to 2 to the 10. But it gives a way of spotting what the pattern is. And then that takes us on to the next step of the question of actually saying how many pairs there are. If you can't spot the pattern, it's so much harder to say how many pairs there are and actually get the answer. So yeah, that was a nice question. That was a really nice block of 10, actually. That one was nice. This one was interesting with a polynomial. That was a bit different. Okay, that one, the trapezium one, sucks. That was a rubbish question, really. G was a bit different with the graphs. That had something different about it. I really liked F. E was a nice substitution. I think these are all pretty challenging questions. Okay, D was quite straightforward. C was fairly straightforward, but even then, for early questions, C and D, they were more difficult than you might expect. B was a nice geometry one. A was, yeah, nice. I would say, with the exception of the trapezium rule, that was a really nice bunch. Not an easy bunch, but a good set of questions, I think, all in all. Right, so that wraps up those. I'll be back with question 2 in the next video.